Okay, so let's think of two-dimensional motion, and let's try to describe this motion in terms of vectors. So let's say that we use a coordinate system where that's x and that's y, and so the vertical direction is the y direction and gravity is acting, and we are, say, at some height L, and we launch an object from that height at some speed v naught, and there's some angle there, theta, let's say, or theta naught. Let's find the acceleration, velocity, and position vectors in this two-dimensional space. So the acceleration of the object, right, we can start from there because we know that gravity is acting, but that's in the vertical direction, which is the y direction, so we have a minus g j hat, and if we threw numbers in and we were using units of meters and seconds, this would be 9.8 meters per second squared. But that's the acceleration vector. It only has one non-zero component. So let's see what happens to the velocity vector. So when we integrate this, right, we integrate to get an x component and a z component, but what they say is that because there's no acceleration in the x direction, we have no, well, maybe let's write this down. So Vx would be, we would have some V naught x plus axt, but this quantity is zero because the acceleration vector has no x component, and so we just have to look at the initial condition, the integration constant. And so what is the initial velocity in the horizontal direction? That's the part of this along the projection of this along the horizontal direction, and that involves v naught cosine of theta naught. And so we have that in the x direction, and that, notice, is just a constant. It never changes. So we have the x component. The z component, similarly, let's just write it down. So Vz is equal to V naught Z plus AZT. This is zero because there's no Z component here. And there's no V naught Z. This arrow doesn't, it's in the XY plane. It doesn't tilt out of the plane, so there's no projection onto the Z direction. And so this is zero. So everything is zero. There's nothing interesting there. We don't have a K hat term. We are integrating the this term, and so we get minus gt j hat, and then we have the integration constant. So the vy term is v naught y minus gt, because we integrate the ay, which is minus g. We integrate that, and we get the minus g times t, so there's that, and we have to add, oops, I didn't give myself enough space, so let's just try to fit it in here. So v naught, right, what is the part of this in the vertical direction, the projection of this in the vertical direction? Well, if the projection in the horizontal is this, then we must have v naught sine theta naught there. We managed to fit it in. And so then we can integrate this to get the position. And so we integrate a constant velocity term, and we get v naught cosine theta naught times t I hat plus, sorry, I'm not paying attention here. The x component is going to be the result of integrating, right, we have a v naught this is what we would call a v naught x. So we have a v naught x, and we integrate that to get a v naught x times t, which is that, but we have to add to that the initial position x. The initial position x is 0, so there's nothing to add there. But now we do the same for the y component. And so when we do that, we have to integrate this term. So we have a minus gt squared over 2. Then we have the v naught sine theta naught t, because we integrate that as well. And then we have to add a y naught, the constant of integration, which represents the initial y position. And of course, what's the initial y position? Well, the object is up here. So it starts at some y value, which is L. And so we have an L plus v naught sine theta naught t minus 1/2 gt squared j hat. And so we have the acceleration vector with one component, a velocity vector with two components, and a position vector also with two components. And we could, of course, evaluate this at different times. So at t equals 0, right, what does the position say? Well, it better say that the object is right there. What does that mean? It means x equals 0, y equals L. And so at t equals 0, this in fact disappears. And at t equals 0, these two terms disappear, and we just get L, j hat. And that's exactly what we expect. And at t equals 0, this disappears, and all we get is that the velocity is, in fact, it has the two components, v naught sine theta in the vertical direction and v naught cosine theta in the horizontal direction. And of course, the acceleration vector doesn't depend on time.